We are discussing increasing and decreasing over an interval. So below we have a cubic function, third degree function, and we want to know over what intervals is it increasing or decreasing. So you might notice that as we move left to right, we always move left to right when we're talking about intervals. I'm coming up from here. I'm coming up, 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 up. I reach a point where I kind of turn around and I start going back down. Down, down, down. And then I turn again and I go back up. All right? So these points right here, where I said I kind of turn around, those points, if you've already watched the max and min video, these are maximum and minimum points. All right? Now, this maximum right here, for our purposes, is -1, and this is at 2, at -1 and 2 for our x's, okay? So I want to know over what intervals it's increasing and decreasing. Now notice, increasing, I'm talking about that if I were to turn this part into a line, I could draw a line right next to it, and that means it's going to be increasing. It's going to be positive. It's going up. Positive slope, right? It has a positive slope right there. Over here, we also, if I were to draw a line right next to it, it is increasing. We have a positive slope. Over here, right along the middle, I have a line that if I were to draw it right next to it, would be negative. I would be decreasing. And notice, no matter where I draw that line along this point, I could even come clear in here and draw the line right here, all the way up to that point. I would still be going down. I would still be decreasing, okay? So this means that for this function, it is increasing over the intervals. Let's see. Well, it's increasing from, as far as we can tell, clear from negative infinity. So in interval notation, that would be negative infinity to this point, -1. Now we need to determine, do we want parentheses here or do we want a bracket? Now, when we're increasing, let's think about that line that I've been drawing. If I drew a line right there, right at that point that touched it, that line is going to be flat. So that means that I am no longer increasing, nor am I decreasing. So I am not including that turning point. I need to put parentheses right there, all right? Now we are also increasing from here up. Now, same thing. Am I including this point right here at 2? No, it's just my end point. So I have 2 to infinity as increasing. Okay. Now, this is in my interval notation, correct? If I wanted to write it in inequality notation, I would be writing that it is increasing over the interval when x is less than -1, not equal to, and x is greater than 2. Now, this is decreasing over the interval -1 to 2. It's this interval right here. That's when it's going down. So -1 to 2. And again, we are not including those endpoints because it is not actually increasing or decreasing at those points. It is flat. Okay? If I were to write this in inequality notation, I keep blanking on the word, I would say that it is decreasing when x is greater than -1 and less than 2. All right. So hopefully that's a good introduction to increasing and decreasing over an interval. Let's go ahead and try out some examples. So example 1 is asking us to identify the intervals over which the function f is increasing and decreasing. This is our function f over here. It's a weird one. We want to see when it is increasing and when it is decreasing. All right. So let's come over here. Let's see. I start out by going up. I'm coming in from somewhere and I'm going up. Then I hit that turning point and I start coming down. Then I go back up. Then I come back down. Then I go back up. And then I come back down. Then I go back up. And start to come back down. We don't really see much of it. Okay? So this one's going to have a few intervals. It is increasing from what we can see, because this graph probably continues on forever, let's just go off of what's on the graph, okay? So, because this may go down, we're going to assume that it goes on forever that direction. So it's increasing from negative infinity to, what is that, negative 4.5? We'll call that negative 4.5. And union with negative 3 to negative 1.5. Union with 0, yep, to 1.5. Union with, it's not really 3.5, but because of what we've been doing, let's go ahead. Well, it's probably more like 3.25, right? 3.25, we'll call it 3.25. Up to 4. Where I drew that is about 4.75. All right, so those would be our increasing intervals. Now our decreasing intervals, we are decreasing from negative 4.5 to negative 3. Union with negative 1.5 to 0. Union with 1.5 to 3.25 is what we decided. And then we don't really see much of this part, but 4.75 to infinity right there. Now remember, we're not including these turning points, right? Even these points right here that are jagged, right? It doesn't have a slope at that for those points. Okay, that was a long one. Let's go ahead and try example 2. Example 2 is multiple choice. We want to select out of these intervals over which ones is the function f of x decreasing. All right, so we just care about decreasing in this case. So looking at this interval right here, this is when x is greater than negative 4.5 and less than negative 4. Let's go ahead and check out where that is on the graph. I'll use a highlighter. We'll bring it down in size. Okay, so greater than, actually I'm going to do it up here. Okay, there we are. Greater than negative 4.5, so about right here until, I changed my size, I want a little bigger. All right, about until negative 4. Oh, it's just until negative 4, right here. So over this interval, what is our graph doing? If we look at it, it's about right here to up here. Our graph is increasing. It is going up, and we're looking for decreasing, so it cannot be A. All right, let's look at negative 0.5 to 0. So negative 0.5 to 0 is, now I've got way too big of a highlighter. All right, negative 0.5 to 0 is right here. So that is about from here to the 0 point. That is also increasing, so that's not going to work. Let's look at this last one over here. We've got 1 to 2 right here. So I've got this point up to here. That is also increasing. So it looks like our answer is going to be none of the above, because the intervals over which it is decreasing are right here, which was not any of our answers, and right here. Okay. All right, example 3. We are going to, you can ignore this part right now. I probably should have covered it up before the video, but I'll just do this right now so you can't see it, even though you could pause it and fill it in. There we go. That's probably even more distracting. We'll make it a light purple. There we are. Okay, so consider the polynomial function g of x equals negative 0.5x to the fourth plus 3x squared plus 2. So how can you use a table to identify intervals over which the function is increasing and decreasing? So let's look here. Increasing and decreasing gets determined from the y values. So as we move from this y value to this value, we are increasing. So this is showing increasing. As we move from 6 down to 4.5 down to 2, we are decreasing. As we move from 2 to 4.5 to 6, we are increasing again. And here we are decreasing. Now, here's where this note comes into play that I had over here. You'll notice points where the function values change from increasing to decreasing, or vice versa. So these points up here is what it's talking about, these points where it changes, okay? They are turning points. This function has approximate turning points, but we can't actually determine the exact turning points, because notice how there's some overlap here. We don't actually know exactly where it's turning. So we know that it's turning somewhere between -2 and 1, or -2 and -1, I apologize, between 0 and 1, correct? Yes, between 0 and 1, and between 1 and 2. All right. But we don't know exactly where those turning points are. So that's the best approximation we can give. So we actually cannot, from a table, usually determine increasing and decreasing intervals. It's very difficult. So those will not be given to you on tests unless it is asking you to pick some interval where it is increasing. We know from here to here that it is increasing, but we don't know exactly when it turns around. Okay? So tables are a lot more difficult to identify increasing and decreasing. From a graph, however, it's not hard at all. We can easily see when it is increasing or decreasing.